So hi everyone, today we're going to be looking at rounding errors. So let's start with example 1. The mass of a cake is given as 4.3 kilograms to the nearest 0.1 kilograms. Find the interval within which m, the actual mass of the cake, lies. So what's this question actually asking us? So the question is saying to us, we have a cake and we know that the weight of the cake is 4.2 kilograms when we round it to the nearest 0.1 kilograms. So if you go back and you check lesson 7, you'll know that when we're rounding a value, so in this case, when we're trying to get 4.3 kilograms, if we had something like 4.25 kilograms, because this decider unit here is greater than or equal to 5, we know that this value is going to round up to 4.3 kilograms. Similarly, if we had something like 4.34, then because this decider unit is less than 5, we know that this is going to round down to 4.3 kilograms. So that's basically what this question is asking us to find out. What is this range? What is this range of values that the actual cake can weigh so that after we round it, we end up at 4.3 kilograms? So we know that if it weighs anything more than 4.25, it's going to go to 4.3, but it also has to weigh less than 4.34 to end up back at 4.3. So that's one of the ways you can work out the answer to this question, if you're very, very comfortable with rounding. There's another way as well. And this second method, if you take this 0.1 kilograms that you see here, so that's our rounding unit, and we divide it by 2, we end up at 0.05. And then we take our 4.3 kilos and we minus 0.05, which gives us 4.25, which is that lower bound that we saw here. In other words, this is our minimum value. And then we do 4.3 and we add on the 0.05. And this gives us 4.35, which is our max. Kind of. So it's not really our max. Because the problem is, if the actual weight of the cake was 4.35 kilograms, then it would round up to 4.4. Because this decider is equal to or greater than 5. So it would go to 4.4. So the cake can never actually weigh 4.35 kilograms. If it weighed 4.35, after rounding it, we wouldn't end up back at 4.3. So how do we actually write this answer then? To show what the range of the actual weight of the cake can be. So we start off with writing 4.25 because this is our lower bound, this is our minimum. And we say that m, which is the mass of the cake, has to be greater than or equal to, which is what this line means, 4.25. We also know that we have this 4.35 value and the weight of the cake has to be less than 4.35. Notice there's no line here because we don't want it to be equal to. If it's equal to, like we said, it will round up to 4.4. So it has to be less than 4.35. And this here is the actual range that the cake can be. And that's what rounding error is. So even though we thought the weight of the cake was 4.3 kilograms, because it's rounded to that 0.1 kilos, that 0.1 kilograms, the actual weight of the cake can be any of these values here, and that would still look like the cake weighs 4.3 kilograms. So that's what rounding error is. So here we have example 2. So give the error interval for 380 after rounding to two significant figures. So pretty much the same question, but asked in a different way. In order to try to tackle this, we have to really understand what two significant figures means. So I'll give you a brief summary here, but again, go back to lesson 7 if you're not sure, because we did go over it in detail there. So we've got 380 here, and we know that this is the value after we've rounded two significant figures. After we've rounded our original value, we've ended up at 380. So much like the cake, we've ended up at 4.3 kilograms in the cake, and we need to figure out what the actual values could have been. Same here. So we've ended up at 380 and we need to figure out what the original values could have been, and that will give us our error interval. So this is the range of values that are possible that will still look like 380 after we round to two significant figures. So how can we work this out? So a bit of a summary of what two significant figures means. So say we had something like 378. Then when rounding to two significant figures, we count two numbers in, so 1, 2. So 7 is going to be the number that changes. And 8 becomes our decider number. So we look at 8 and we say, is it greater than or equal to 5? Well, in this case, of course it is. 8 is bigger than 5. So we write our number that hasn't been touched. So 3 is neither of these, so that stays the same. And then we look at 8. Since it's greater than or equal to 5, then this gets rounded up. So 7 becomes 8. And then we replace everything else with a 0. So that is how we round to two significant figures. Now the question is asking us, what's the minimum number that the real value could have been before we rounded it to get us to 380, And what's the maximum value that the number could have been, that after rounding we got to 380. So our minimum value, well, we know that if we had 375, because we rounded to two significant figures, we of course count 2 in. So this is our last digit. This becomes our decider. So because our decider is greater than or equal to 5, then we know that this is of course going to round to 380 using the same technique that we used up here. And our maximum, you would think it would be 385, but it's not. Much for the same reason we looked at in the previous example, because if it was 385, of course this would round up to 390. So actually it's going to be 384, because anything greater than 384, so if this number, our decider number, is greater than or equal to 5, then it will round up, so we need it to be less than 5. So of course the biggest number that is less than 5 is 4. So this is the maximum number that it can take on in order to still be rounded to 380. So how do we write our answer? Well, we write it in the same way that we did in the previous example. So we're going to put 380 in the middle, because this is the number we're trying to get to. And we say that when you're rounding to two significant figures, the minimum value is 375. So anything greater than or equal to, that's what this line means, equal to. When we round anything greater than or equal to 375 to two significant figures, it will take us to 380, provided that that number is also less than 384. Because anything greater than 384 will take us to 390 as a two significant figure when we round it to two significant figures. So this here is what's known as our error interval. So as long as the value is greater than or equal to 375 and less than 384, when we round it to two significant figures, we'll end up back at 380. So thanks for watching, everyone. That's going to be our lesson on rounding errors. Be sure to check back next week for our next lesson.